Welcome back. Let us solve another example on Kirchhoff's circuit law. In our second example, we just have a simple circuit here. We have to solve for the current passing through resistor 2 and resistor 1. And from our example here, you can see that the directions of the current are not given this time. So identify the junction, then create the loops and make the direction of the current. Just choose arbitrarily and make sure that at least there should be one current entering the junction and there should be at least one leaving the junction. So this is our question, and here is our solution. So there is a junction. I've chosen this one to be my I3, then this one to be my I2, then this one to be my I1, okay, with respect to resistor 1 and the resistor 2. So there is at least two currents there entering the junction, and then there is one leaving the junction. So using Kirchhoff's current law, current 1 is the only current leaving the junction, then this must be equal to all the currents entering the junction. That is I1 is equal to I2 plus I3. Now the loops, I've also chosen the direction to be clockwise, even in this example. Okay, so I'm moving in that direction, even this side in that direction. Okay, so now using Kirchhoff's voltage law and starting from the battery here in loop 1. So for loop 1, I'm moving from negative terminal to positive terminal, so that will give me positive 1.5. Then I continue the movement and I'm at this point. Okay, the current here is I1 and I'm moving in the direction of current I1. Okay, so the voltage here will be negative I1 times R1, and back to the battery there, the loops ends there. Okay, so I just have this. Okay, and from here, since I know the value of the resistor, that is 100 ohms, I can directly solve for I1, okay, by substituting for I1. So if you do that, then you have 1.5 minus I1 times 100 equal to 0. So for I1, okay, by taking this to the other side, it will be negative, that will be 100 I1 is equal to negative 1.5. okay, so this is negative 100 here. So you divide throughout by 100, even here you divide by 100. What will you get? This is what you will get, and it is positive, meaning that the direction that I chose for current this time is correct, since the answer is positive. Now secondly, using the second loop here and apply Kirchhoff's voltage law, okay, again I start from the battery. So in that direction, okay, clockwise direction, you can see that if I start from this point, I'm moving from the positive terminal to the negative terminal, so that will give me negative 9. I continue with the movement and I'm at this point. You can see that this is current 2, this is current 2 here, okay, and I'm opposing this current in my movement. So this will give me a potential rise given by R2 times I1. This is it here, it will be plus. Then I continue with the movement in this loop. Now I'm at this point, I'm also opposing I1. I'm moving through the resistor, opposing the direction of current 1. So this will also give me potential rise. Okay, and back to the battery there, the loop ends there. So this is equal to 0. Now substituting for R2, that is 200. Okay, R2 is 200 given in the question there. Let's just check. Yes, that is 200 there, you can see. So if you substitute here for R2, then you also have the value for I1 and R2. You also substitute here, then solve for I2. You can pause the video and solve for I2. If you do that, this will give you 7.5 over 200, which will give you 0.0375 amps as the current for I2, also positive, implying that the direction of the current which I chose is also correct. Then proceeding to current 2 to current 1. Okay, we know that current 1 is the only current leaving the junction. Then it should be equal to I2 plus I3. I substitute for I2 and I3. What am I having there? I'm getting I saw for I3. I've calculated for I2 and for I1. So in this formula, I make I3 the subject by taking I2 to the other side. So it will be I3 is equal to I1 minus I2. Then I substitute. After that, this is the value that I'm getting, which is negative 0.0225 amps as the value for I3, and it is negative, which simply means the direction of the current which I chose for this one is opposite. The original direction should be there, and still there will be one current and two leaving. Okay, now I have homework for you guys. So you try this one here. So that's the question there. Try to find the current. Try to find the current through resistor 1, resistor 2, and resistor 3. Also, the voltages across resistor 1, resistor 2, and resistor 3 using Kirchhoff's law. Here is the question. You can copy, then solve for the currents and the voltages across each resistor. Thank you. Don't forget to subscribe if you haven't subscribed. Also invite others to follow my YouTube channel and subscribe so that we can continue with this way. See you next time. Thank you.